Conductivity is the measured ability of a material to pass an electrical current through it. For years, conductivity has dictated the size and the material of the wiring we use in everything from microelectronics to aircraft carriers. But there are exceptions to this. For years, scientists have been aware of a group of materials called superconductors. As the name would imply, they are extremely good at conducting electricity. So good, in fact, that they have zero resistance. Resistance is the opposite of conductivity. It's how resistant a material is to electricity passing through it. As a material's resistance goes up, so does the drop in voltage from one end of the material to the other. A side effect of high resistance is heat. As voltage is passed through the material, it absorbs part of the electricity, and this creates heat buildup in the wire. The amount of heat created and the voltage drop across the material is dictated by its conductivity. Now you're probably thinking, well, why don't we see superconductors in everything? The answer to this is that they don't exist at room temperature and ambient pressure. Even though we've been able to create superconductors for years, about 109 to be exact, they just aren't practical for everyday use because of the temperatures they operate at. For example, mercury becomes a superconductor below negative 450 degrees Fahrenheit, but the process involved to lower it to that temperature is extremely expensive and requires a lot of high-end lab equipment. There have been several advances using composite materials that have brought the temperature up. For example, hydrogen sulfide is a superconductor at only negative 9.6 degrees Fahrenheit, but it has to be under pressure that is thousands of times greater than the pressure at the bottom of the Marianas Trench. The ambient pressure at the bottom of the Marianas Trench is about 0.1 gigapascals. The hydrogen sulfide needs to be compressed to 150 gigapascals. But all this may be about to change. Two scientists who are working at the Indian Institute of Science believe they have discovered a room temperature ambient superconductor. In May of 2019, they found that silver nanoparticles infused into a geometric gold matrix display diamagnetism and zero resistance, the two properties necessary for a superconductor. The research underwent peer review and has been reproduced, and the entire scientific community has very high hopes for the material. Research is still ongoing, but if the material is proved to be a room temperature ambient pressure superconductor, it will completely revolutionize our way of life. Imagine high voltage lines being the size of sewing thread and being able to run for hundreds and hundreds of miles without any kind of boosting. Electric cars will have 5 times the range they do now because of how efficient the motors that power them will have become. Solar arrays in the Mojave Desert could power the whole country because distance is no longer an issue when conducting electricity. Computers will become hundreds of times faster, and quantum computing will become viable at room temperature. There are limitless applications for superconductors, and they are the next step in technology and renewable energy.